Hey Pawan. Hey Pawan. Good morning. Yeah. So Snowflake is again another cloud database, data storage, where it offers the modern uh, data analytics features and of course some AI features as well. So it started as more like a uh, data storage for analytics platform, and then it kind of evolved into providing all the features. Okay. So what I'll give you a brief of what it does, right? So as a database, normally you would have data storage, just like any other database. And then this is completely on cloud. Okay. So Snowflake cloud. Again, when you say cloud, so this is more like Databricks. Okay. You can compare and contrast with Databricks and see what features are similar, basically. But it was Snowflake started more as the database storage and process and analytics layer, where Databricks started as a processing engine, like distributed processing, file processing or data sources, processing layer. And then they added Databricks Delta for faster data storage and evolution. And then they added all the features around it with AI, ML, data analytics, data storage, connectivity to BI sources, and all of that. Um, so Snowflake started as a storage, as a database on the cloud with massively parallel processing, like which can have again your concept of processing the data or with the distributed computing processing. Okay, same thing. So where you can have clusters to run the queries or run the jobs, or for anything. Mostly if you want to access any data, it will give you a standard kind of processing power machines, clusters, which again is can be configurable based on what size you need, what how many machines you need to process such queries, right? So all of that. So some kind of theory here. It's a software as service platform that provides data storage, processing, and analytics solutions. Okay. It's known for its scalability, flexibility, ease of use, and make popular choice for businesses looking to manage and analyze large data sets. Um, so standard, database features, but it's a platform, software as service platform. So what are the key features? Scalability. It automatically scales up or down based on demand. So it gives you that flexibility to scale up or down. This is more on the uh, processing power. Like I said, the clusters, right? It can scale up or scale down, or scale out. So what we will talk about what scale up and scale out is. Data sharing allows secure and easy sharing of data across different accounts and organizations. So you can securely share your data, without extracting or physically sending, or physical instance sending the files or sending it in a particular format or giving connectivity. You can share your data with different accounts and organizations without moving your data out. Support for structured and semi-structured. It can support JSON, Avro, ORC, Parquet, and XML formats. You can store all of those in the uh, in Snowflake. Concurrency and performance. It separates the storage and compute, ensures high concurrency and performance. So it has three different layers that we will see in the architecture. The storage is separate at the lowest level. This storage, again, it uses one of the three hyperscalers, the cloud platforms, um, Amazon, AWS, or Google, or Azure. One of these three you can choose, and then it'll use that to do the storage. So storage layer is different. And then on top of that, you will have compute layer where it will spin up the machines to run the queries, to interact with data, to do all of those heavy lifting, all the processing. It will create the compute. So these two are separate. Storage is separate and compute is separate. So zero copy cloning, basically what happens when you want to clone some data. Okay, so let's say I want to have two non-prod environments, dev and QA, but I want to clone the data. But when you there's zero copy cloning will give you, so when you clone it, only the definition will be cloned. Not the entire data will not be copied. Like you don't create another copy of the entire data so that you don't um, you don't create more storage. Same, if you have 10 records, after you clone in the storage, there will be 10 records, same 10 records, but the two tables will be sharing that data at that point of time clone. After cloning, zero copy cloning, then whatever transactions you do, it will be separate for both the tables. Okay, so it will start with whatever is common base. It will share that data with the both the tables, and then you have the kind of metadata. But as you go on and start changing the definitions or manipulating data, it will continue to add to differently for both the tables. So basically, that's a zero copy. So zero, you can clone, but data is not copied. It's just the metadata is copied. So time travel, again, same you also have in Databricks. We'll talk about it in the Delta when you go back and go and see what are the features of Delta. What is time travel? It's basically allowing access to historical data with a defined retention period. Okay. Historical data snapshots. It keeps historical snapshot for your data. Okay. Basically, let's say if you have modifying a record. So all that history snapshot. So yesterday, say you have like updated phone number from 100 to 101. So your data will still show 101 latest, but you can go back in history and say, hey, show me what was the phone number on this date. So it will show 100 at this date. This was 100. Okay. So like that, you can go back in time and see the snapshot, look at data, how it was at that point of time and that interval of, as a snapshot version, because each normally I think it creates version. So at that version or at that time, you can go and see the snapshot, how it looked like. It's more like you are taking a backup and going back and looking at that backup, but it's not a backup. It automatically takes care of creating versions and snapshots as you do changes to your table, either schema or data or everything. Default, I think enterprise up to 90 days, you can go back and do time travel and look at it. And then if you feel something that was wrong, say yesterday you processed something wrong, so you can roll back or make sure roll back your table to as it was on the day yesterday before processing. Okay, you don't have to do again all run rollback processes. You can just go and say a rollback table to this version or to this table. So it will go back to the time, and then you can do the processing again from that date. So that's the benefit. Secure data sharing that we talked here. End-to-end encryption, both in transit and rest. So when the data is in rest at storage, it is encrypted. When it is moving also, it will move the encrypted data. It's the same thing with Databricks as well. In the Parquet format, it is already encrypted and stored in Parquet format, and it is compressed. So same thing here, it is encrypted in transit and at rest. Okay. Data integration supports seamless integration with data integration tools, BI tools, and ETL process. Of course, that is needed because you have to integrate with whatever BI tools, ETL process, everything, you have to integrate with this. Multi-cloud support, as I said, you can choose AWS, Azure, and Google Cloud. Automatically optimizes data storage and query performance. So it will automatically optimize the storage and performance. So this is the architecture, basically. So you have any questions here? It's just the features, and there are a lot more. There's very highlighting very few of them. You have any questions on this? On any of this?
No, I don't.
Okay. So at the very basic level, just think of it as a database which is on the cloud, which allows massively parallel processing. These are called MPP databases. MPP, massively parallel processing. Okay. So MPP database, it has a storage and it has a compute layer and it has a configuration or what you call this uh, cloud services where you do authentication, all of that configuration layer. Compute and storage is separated. Compute can be configured based on roles, which departments you can store, who's using how much power and all of that. And then it has all of these features like zero copy cloning, time travel, secure data sharing, multi-cloud support, structured and semi-structured data, all of this. Okay. And all of these features, most of them or all of them are also available on the Databricks Delta. The architecture, if you look at, so we'll see different perspectives or representations of the same thing. So at the lowest level is the database storage. Okay. Under this, again, it will be like cloud, AWS or Azure or GCP, where it stores the data. And then it manages through its database storage. And then you will have a query processing layer where you will have warehouses. Okay. In Databricks, what do you call it for processing? When you log into Community Edition, what do you create first?
Cluster.
Yeah. So compute clusters, right? The same compute cluster here, they call it virtual warehouse or just warehouse. Okay. I don't know. It's a little confusing because warehouse, you normally talk about when you say warehouse, you think about data warehouse storage. But here, warehouse means processing power, processing machines. Okay. Virtual warehouse. You see number of the gates, it means that each warehouse can have different configurations like size of the machine, number of machines in that warehouse cluster and all of that. When these machines will interact with the database to run the query and get the data. Now at the top layer, you have authentication access control. Basically, when you log in, all of that, whether you are, authentication, what is your access is all managed here. Infrastructure, optimizer, metadata, security, everything is in this layer, cloud services layer. Okay, these are the three different layers. So another representation here, you can see like same thing. At the core is your storage. On top of it, you will have query processing, and on top of it, you have cloud services. So whatever you do, it goes through cloud services, then to query processing, and then to the storage, and then comes back. So what are these three layers? Cloud services layer coordinates and manages the Snowflake system. It handles authentication, infrastructure, metadata, query optimization, and access control. Query processing, this layer is responsible for executing queries. Okay. Snowflake uses, as I said, right, massively parallel processing, MPP, compute cluster, where each node stores a portion of the entire data set locally. This allows for efficient query processing and high performance. So basically, when you get data, it is again distributed between these machines and processed parallelly. So that's how you get the parallel processing in the Snowflake. Storage, again, it is organized into an optimized, compressed columnar format. Okay, so this is very important. So it stores in the columnar format, and also it has uh, something called micro partitioning. Okay, which means data is already partitioned in micro partitions. Each partition is less than, I think, close to 50 MB. So it will partition itself as micro partition so that data access is faster. So two things you have to remember here in the storage is it is a stores in columnar format and it does micro partitions. So you don't have to create again indexes on the columns and this and that. It already takes care of columnar formatting, columnar storage, and your micro partitioning. So these are the two things. Here at storage, at processing, it does massive parallel processing using compute clusters. So parallel processing happens here. So this are different, like again, when you go a little bit into the next level, it talks about what are all the components of the Snowflake. Okay, so you have the table, then you will have some kind of stages. It has some stages basically where you can get the uh, stages like, yeah, mount point or a space where you are loading your source data. Like for example, maybe it can be a file storage. You create a stage and then upload your files there, and from there you can copy into the tables. Named internal stage, external stage. So internal is basically stages close to within the Snowflake. External can be outside. So users can have their personal storage as well based on their user ID, and they can use it. Or table stages for shared access to table specific files. So these are different types of stages. You don't need to worry too much about this at this point of time. Maybe you have, once you get comfortable with this, you can explore. Um, each user in Snowflake has personal stage by default. Each table in Snowflake has stage allocated by default. Internal stage for more flexibility, named internal stages. And then there are external stages like, just S3, for example, Azure Blob Storage, Google Cloud Storage is what we talked about Databricks, right? When you are connecting to storage externally to S3, you can go and connect to S3 and read files and read data. That's the same thing you create here as an external stage. You give location when you create a stage and say, hey, this location, this stage is pointing to this location on S3, and then you give all the credentials to connect to that location so that you can connect and read. So how do you load data into database? Is like there's a three-step process. First, you create a stage. It can be internal or external. Then you put the files there. So if you want to use, say, let's say external, it will already be there in S3. If it is internal, you upload the files there. Use the put command once you download the CLI, command line interface. You upload the files into the stage, and then you use copy into command to load data into the file, into the table. So that file gets copied into the table. So in Snowflake, so you can write the queries, or there is something like you can create snow pipe or stored procedures to process the data. So how does the commands look like? So basically, when you download the CLI commands, so you can say, once you are connected to Snowflake, you can say put your file, whatever is the local file on your computer, to your personal stage. So this refers to user stage at the rate tilde. Then you can say list at the rate tilde. It is a shortcut format to your user stage. Okay. So it will list all the files, and then you copy into any table from this location. So what is the format of the file? and what you want to do on error and this kind. So this is just an example how to do it. So we will explore this later when you get this CLI. So table stage is also similar. It's just talking about different stages, right? This is user stage, this is table stage. At the rate tilde was like user stage, and at the right percent table is your table stage. Okay. And then you have named internal stage, right? So we talked about 4 stages, correct? User stage, table stage. These are default created when you create a table, when you create a user. But these are the stages that we normally work with: internal stage, external stage. So when you want to do internal stage, you have to create stage, whatever stage name, and then put the file to at the rate that stage, and then copy into table from that stage and all of that same. And then you can remove files from stage, and then you can describe all of these commands. So you're actually kind of, you don't know if you have, Windows, when you connect to a external machine or network, you create a mount point pointing to that, or Unix, you create a mount point which is pointing to that file location. So same concept here, you create the internal stage. So all of this you don't need to worry right now. Just these are some concepts. Stages is just how you get the data in. But for now, let's just focus on this part. Okay. What is the architecture? Database storage, query processing, cloud services, and how it processes the data, and what are the features. Any questions? Guys?
From my side.
Okay, at least you got high level.
Yes.
Yes.
Yeah, high level we got it. Yeah.
Okay, that's fine. So what we'll do here, so you can, again, just like community edition, right? So you can go and create a free account, but it is valid only for 30 days. Okay, 30-day free trial you get. So you can just go start your 30-day free trial. Okay, and then give some details here: name, work email, you can give any email, and say personal learning and all of those details, and you get the free trial. So once you can also, just like community edition, right? You select which cloud you want to use for storage and all of that. So once you get that, you can log into the Snowflake account. Okay. Let me here. My Snowflake account. One second. I'm trying to get into my Snowflake account. Okay, can you see my screen?
Yes.
Okay. So you just go create account, create user password. Okay. So it will look, you'll get into like this, basically. You can open any of the worksheets directly and work on, or notebooks you can create. But first we will go and look at, so all of these are available: projects, data products, AIML, monitoring, admin. Okay. You get $400 of credits to, in 30 days you want to explore and work. So if you go here, it will give you the profile. So if you go to profile, you'll also have an account. I used AWS, so that will give me my account. So if you go to profile, it will tell you what is username, uh, password is default role, account admin, and warehouse is compute underscore WH, which is extra small. So this you can use, like, what is your role and what is the cluster or warehouse that you are using. You can also get um, so here, if you click on connect a tool to Snowflake, so here you will get all the configuration details. So what you need is your account. So this, if you see, WQFFJPU is coming from here, URL WQFFJPU, and MK74449 is your account ID. Okay, snowflakecomputing.com. So this is the entire URL. Okay, you can copy this. Username you will have, role you will have. These are important. Account name, organization are okay. You can just know that they are there. Region, cloud platform, all of this. Only these things. Okay. Default port, it will take. You can use default port. This is the what you need. Main things are your account, username, role. You will have a password, right? So for the username, you already have set up a password. So that password, and then role you have, and you also know the warehouse, default warehouse, what you are using. So all of these you need to connect to the Snowflake. Okay. So remember this. You will need that. Then you can go and create worksheets. So these are all the worksheets. So you can open any uh, worksheets. You can have some tutorials. You can look at load sample data with SQL from S3 bucket, with Python from S3 bucket, adding a user and grant. So don't go here. So that's later. Sample queries and all of those. So if I just go and open this, it will give me some kind of a template. Okay, if you don't have this, don't worry, because I was exploring, looking at, it might be visible here, but if you just go and check Snowflake tutorials, or when you create the account, it will give you, an option to click on tutorials, Snowflake tutorials. You can go and check that out. Here it's showing normal database stuff. So, what is the role? Account admin. What is the warehouse compute that you want to use? Create or replace database, schema, table. Okay. I create a database, create a schema, create a table. This is the table, tasty byte sample data. Yeah, database dot schema dot table name. So 3-level representation. Okay. So database, schema, table. Now what they are doing is creating a stage here, like we did, right? So we said we'll have to create a stage first. So they are creating this database default public schema as a blob stage. So this is from URL. So they are pointing to this URL on S3. So this might be public, so you can access. File format, type equal to CSV. So when you list, it will show what are all the files. Then you're doing copy into this, and then all of this stuff. Okay. just looking into the SQL queries when you are load the data into the tables. Now going back here, so if you see here, once you go, they will by default give you two databases. There is a Snowflake. Okay, this is internal, where what it uses, what is your account usage, tables, images, data sharing, marketplace monitoring, all of this, Snowpark, telemetry, all of this. So this is kind of internal. But this sample data, you get another database called Snowflake sample data. In this, you have different schema. It'll have data. So if you want to have 10 TCL, 100 TCL, in this you have tables to practice, and then you will have all of these uh, data in these tables. Okay, so what the features, if you click here, right? So it will give you details. So the moment you just point on it, you can get all the high level details of the table here. It says what are the number of rows. You can see here 2000. What is the size of the table? What is cluster key, owner, when it was created? You can look at, it's not showing definitions. Okay, for shared database, okay, definition it's not showing, but normally if it is your own table, you can also see the table definition directly here. And then you can go, you can copy this table onto the editor, name, view definitions, load data. You can do any of this. Okay. This. Just click on the table. You get the metadata here. Okay, so these are all the columns and data types definition of the table. Then you can go see here preview data. You can click preview data, so you can see the sample data here from the database. Okay. Any questions? So go ahead, create the account, look at these objects, and then we will talk more about it. Now, asset worksheets. So just sample worksheet, select star from, so databases. If I go here, sample data 10 TCL. So what I did here, I just put tables, say catalog returns. If I want, I'll just click here, place name in editor. So it will copy here, database table, this thing, and do select star from. I'm already using this role and this warehouse here. It default selected. I have not created anything new, so it uses the same thing. So I can just select and run this data, and then it shows Snowflake executing. How much time it's taking? It's taking so long. How much data this has? Oh, 1.4 billion. Let's cancel. I don't want to get my credits. So when you are doing, right, since you are on the trial account, so don't burn your credits. Take tables which are smaller, okay, and use those. There's 65 million, 1.4 billion rows, right? So don't use all of that. Take smaller ones and work with those. So income band, let's see. So I have only 20 rows in this. So I can go and to this. Okay, so that's how you do normal, select just like your standard any SQL clients that you use like dbeaver or Toad or anything. Same thing here. You can use all of this, but the additional features like I shown you like this here. Okay, now let's go back and try this. I haven't tried this. Maybe we'll try to uh, run this, and from there we'll see. When you said right, want to connect external tool. So basically, we were having Databricks platform as our center and then building all these sources around it, right? So we will again say take the same approach. We were connecting S3 to Databricks. We are connecting Azure Event Hubs to Databricks. Then we connected Kafka to Databricks. Now we will connect Snowflake to Databricks. Okay. So how you can interact with all of this kind of things. If you look at the pattern, right? End of the day, Databricks code does not change to connect to any of these, only the configuration changes. You have observed that how you connect to S3 is different from how you connect to Event Hubs to Kafka. Each tool needs those parameters, the credentials to connect to. That's all changes. So once you have that and you read, you get a data frame. And once you get a data frame, you are in your own Databricks world. You don't have to then worry about where it is coming, how it is coming, and all of that. Okay. So same thing here. Let me, since this is new, I will run use account admin. Compute warehouse. I'm creating a database. Okay. Database is created successfully. Refresh this. Say now you got the database. So by default, you get information schema and public when you create a database. Now you can create a schema. So you refresh again. Now you get your schema here. And now you're creating a table. Okay. With all of these details, run, created, raw position, go to tables. How I to remove this? Just put it on. Menu. This is the table. It's created. I don't need select star from. No results that we know. Now let's go here and see whether if this works because we need to have access to S3 for this. And then we are creating a stage, blob stage. Okay. So tasty bytes public. So if you go here, refresh, this is the database. Now you have to go to public schema. In this, see you have C stages. So there is a blob stage that is created. Okay. So you go to blob stage, it shows, see here, type, it is an external stage. Okay. Region, cloud, AWS, US West 1, owner this, created just now. Now you can go and use list. So there is this file there in S3. SF quick starts, tasty bytes, raw pos menu / menu.csv.gz. So this is the file. It is on the S3. So now we will read that file and then copy into our table. So copy into this menu table from this raw pos menu. So this is our blob storage. So when I'm pointing to this blob storage, it will read the files from this blob stage, raw pos menu, and it will copy into this table. So it says loaded 100 rows. Now we can go back and check our table 100. So simply you can directly, as long as you have access to that X3 and then you create as external stage. Now you have direct connection. You established a direct connection to that stage, to that S3 bucket of folder files. So you can directly use copy into and then give that folder bucket name in that stage. So it will read the files and then it will move the data or copy the data into the table. Then you can do select top 10. You can also do where clause. It's all like same thing. So don't worry about this. Just normal SQL that you're doing. Some aggregations, calculations here, right? And then 1 second. So now we go here, tables, menu. So if you see here, menu item health metrics obj, right? So what is this data type? What is the data type here?
This variant it shows.
Varchar.
Is it a varchar? What does it say
It's
here?
just a variant. Shows variant.
Right? So it's a variant. Variant means it can have an array or a object, JSON object, it can hold. Okay, variant data type. Now, how you can parse that variant data type is like this. So table M input health metrics object colon menu item health metrics. Your just like we did in the JSON for formatting, right? Parsing in the Databricks, explode. Same thing you are doing here, flatten for each row from this. Okay, so then you get object dot this obj, you get dot value as array. So don't get overwhelmed about this. I'm just showing you the feature. So don't go into this right now. You can get to that later. So menu item is this. You are getting ingredients from this like this as an array of all the elements. You read all the elements and get it as an array. What you need as ingredients. List of items. Okay. Go here. See here, if you see, this is a JSON object.
Yeah, it's a JSON object call.
Right? No item health metrics. In that you have array. In that you have ingredients as an array. So you are extracting this and then getting a items ingredients into a separate array here. Okay, so this is about creating database, creating tables, adding data. Uh, just from I have shown you the existing sample data set, querying data, and then we have created a stage, external stage, pointing to the uh, lab, so pointing to S3, sorry, bucket, and then we have loaded that data into this table and querying that table in different ways. And also using a variant data type, you can flatten things like this. Okay. This is the foundation basic. And then you know about roles, you know about the warehouses that you use, compute, storage, compute, and then your configuration security layer, 3 layers architecture. Scales, you have scale up, scale out things. Basically, when you say the, remember I was doing, we tried some query where it has 1.4 billion rows, right? And it was going on running. Now, in such cases, which your compute WHX small does not work. Okay, it takes 10 minutes, 20 minutes, whatever time it takes. Now, in those cases, what you do is you scale up. Okay, scale up is you increase your warehouse size to say medium or large or Excel or whatever. That will work on this. Now, if you have, so this is running this query, and then there is some other query that is coming in. But this compute is already, this machine is already full. So what you do, it cannot take any more query, it gets queued. So there are 10 users firing queries and they are all queued up. So increasing the size will not help because that's already executing a query, right? So that case you do scale out, scale up and scale out. Scale out means you add more machines. You don't increase the size of this machine, but you add more machines parallelly, maybe small or medium or whatever. So that right now you have one machine, then you add two more machines. So the first machine is still doing this thing. The second machine will take the next query. The third machine will take the other query. So it's like parallel processing, right? So these machines will start executing the queries in parallel so that your queries don't queue up. So when there is queries queuing up, you need to do scale out. When the queries are taking long time, you need to do scale up. Okay. Of course, scale out also. Same query also can use multiple machines within the warehouse that you can do. All right. So that is the fundamentals we learned about. We looked at external stage and copy into load and all of that. Don't look at the first thing I shown you, right? The command prompt, Snowflake CLI. So don't go there yet. Just work on this cloud thing. Create an account, login, and just browse through, play around, look at data, write SQL queries here, and make sure you are not firing queries on large tables. Okay, check small tables and do fire and queries, and then try this creating this external stage, executing this step by step. All right, any questions?
Harun, does this support streaming or real-time processing like Databricks support or?
It does, yes. Because you have, right, so when we looked at, you have notebooks, it has something called Snowpipe, there's something called Snowpark. Snowpark is like Snowflake using Spark again. So you can write, you can execute your Spark notebooks also in the Snowflake. Okay, and snow pipes, and it has tasks and snow. It has its own um, tools to do stream processing as well. Yes.
Okay.
Okay. You can explore all the features, or I'll just giving you a foundation to start with. then we can explore more on what it does, features, and all of that.
So in the Databricks also we can maintain the tables, like we process the uh, files are either CSV or different formats and store in the database tables, right?
Yes,
And this also does the same, right? I
yes,
mean, processing the files. Okay.
yes.
But
Yeah,
when
this
we
is the
integrate
same.
with the data, okay, when we
No.
integrate the database,
Mhm,
Databricks with the Snowflake, so we
mhm.
don't have to go parse the files like we did for CSV and JSON files for processing. So we don't have to do that, and just if we implement that in Snowflake, and we can just connect to the database and get the data.
Yeah. So it's about how you want to use, right? Some organizations use completely Databricks, some use completely Snowflake, some have both. Okay. Use Snowflake for storage and then you use Databricks for processing and ML and AI use cases, because some are strong. Databricks is strong in uh, s- processing and connecting tools, and ML and AI use cases and all of that is very strong. Snowflake strength is in storage and more database kind of a stuff, right? It has all other features also. Both of them have all the features, but they're playing to their strengths, right? So if you have data in Snowflake and then you want to just keep the data there, but you want Databricks features, you want to integrate and read, you can as well do that. So you can have data ingestion and storage in Snowflake, processing and AI ML in Databricks. You can do all of that communicate all of that. Yes. Or you can do same. Why do I want to maintain two different things? Databricks also offers the storage and
Mm.
processing delta. It has a robust platform. So it can also ingest, it can connect to any of these sources, read, stream, batch, process, keep the storage in house in the delta, and then you can directly use that in the AI and ML or analytics dashboards, everything there, right? You don't have to look out for anything extra. Everything is available. If you have already Snowflake, I don't want to go to Databricks. Yes, Snowflake also you has all of those features. You can use any ETL tool, Informatica. You can connect for processing files and writing to Snowflake from different sources, or you can directly connect from Snowflake. It has notebooks. Same thing. You can explore. Pretty much everything can be done. Okay, it's only that which is better,
Okay.
right? And simple kind of a thing. Okay.
What is the processing layer here? Like Databricks, we run batches.
Yeah, that's
I
what
can
I
see
said,
the
right?
database.
Here
Like
also
what?
you can
What's that?
write notebooks.
Okay, notebooks. Okay.
You can also run those notebooks. Here you have a studio features, models, uh, query, copy history, and one more feature. Sorry, I think we missed out in the deck is one more. There's one more feature which is very, very important, is caching. Okay. Snowflake has internal query caching, which means that when you fire a query now, and then when you fire the same query in 2 hours, it does not execute it again. It stores the results in the cache, and it first compares, hey, does this query been run in the last 24 hours? Yes. Then go check, hey, is the data available in the cache? Yes. So it'll just take that data and give you. There is no processing or computing again. If the query has changed, okay, then go to the cache, execute that. Sorry, then go to the tables, execute that, give the data back, and again store that in the cache. So for next 24 hours, again, it will use that. So there are different levels, right? So there is a query cache, there is a compute warehouse cache. Okay. So at different levels, it stores the cache and it will reuse the cache so that your computing is process is less. So that's another important feature in the Snowflake for the caching of the queries. And see here, you have worksheets, notebooks, Streamlit, dashboards, app packages. Uh, you can go and get star. So make your Snowflake data come with powerful notebooks that you can use. I have not explored. So you can use a name, notebook location, what warehouse you want to have run on this warehouse, create. Okay. Same thing, notebook you get Python, SQL.
Oh, okay. Right. Okay.
Okay.
You can still.
Yeah. Same thing. Yeah. Python, SQL, Markdown, all same thing.
So,
I have
what is the main difference then between Databricks and Snowflake? And what is the best scenarios we choose?
So what
Which
is the
scenario
difference
we choose?
between Oracle and SQL Server? What is the difference between SQL Server and MySQL?
No, but
Right?
we need to understand where the scenarios, which scenario or which case we need to go. Uh,
Scenarios is okay. See, that's what I'm saying, right? You have to play to your strengths.
mhm,
You know, when you know the features, you can go, hey, which one is best? Okay. If I am doing an assessment for a client right now, they have some legacy systems, Oracle, and they have some legacy ETL written in some language,
mhm,
um, which is not Python or not uh, Scala or Spark or whatever, um, something called Groovy something. They're using that language to do the ETL, and they have Oracle database. They have, I think, Postgres. They have some CouchDB. They have something, some different things on prem. So when you're doing assessment and you want to do some recommendation, the standard fee platforms that right now for VR, they don't have streaming right now, live data. So that we are evaluating our Snowflake and Databricks. So what we are evaluating on, we evaluate on all the features. Data, first thing, storage. What features does Snowflake offer with respect to storage? What does Databricks offer? For batch processing, what does these two offer? For streaming, what these two offer? For like data um, compliance, governance, what does Databricks offer? What does Snowflake offer? Like users, roles, role-based access, authentication, security, and all of that. Data masking, right? And then encryption at rest, encryption in flight, in travel. All these features you list down, and then you put what does Databricks have, what does Snowflake has, and you do some points. You come up with score and say, hey, this is strong in this is strong in this. If you go to ML and AI, Databricks is very strong, which has all the experiments, foundation models, hosted models, paper token models, experiments, sandbox. Everything is there. Okay. From ingestion, all the data that you have ingested, you can use the same Databricks Delta. They have inbuilt vector database. They have that you can use. You can connect, use their own DBRX instruct if you want, or they have hosted some models you can use. You can connect to external models that you can deploy. They have Mosaic AI, their own ML platform that you can use. So that's very strong, right? So when it comes to Snowflake, it's limited. So on that storage and query processing, maybe Snowflake is stronger than Databricks. So you do compare and contrast. It's like evaluating two different products and see this is their strengths. Then what does the client want? That's the third dimension. So what are the use cases they have? So let's say the client is not at all interested in AI stuff. Then what will he do with taking Databricks so many AI strong points? Maybe he needs more storage and query. That's what his use case is. Then Snowflake is best for him. But he is heavily into future, want to build strong AI use cases. Then Databricks are strong, should go there. So something like that, you have to compare, contrast, and evaluate.
okay.
Okay, and then cost, of course. what is
Yeah,
the
correct.
cost of total TCO, right? Total cost of ownership.
Yeah.
What is the how? Almost everybody is now only on usage basis, pay per usage enterprise. So how
Yeah.
the or how much storage and how much compute you would get, how much, what was the bill estimated bills you get. So all that you have to take into account,
Yeah, that makes the total difference, right? Yeah.
right? So that's how we do it. Yeah. So this is all there. Then you can, same thing, like you can start, you can run all of this. Basically, looks same, right? What you have done earlier. Now let's go back and connect. Look from our Databricks. Okay. Let me start my Databricks login connection. Where is my Databricks? Okay. Can you guys see my screen?
Yes, yes, Varun.
So basically, how I can connect to Snowflake from my Databricks. Okay. First thing, let me start my compute here. While that compute is running, so Snowflake already gives you inbuilt connector to connect to Snowflake, so you don't need to import any libraries on this cluster, like for Kafka you did, or for Azure Event Hubs you did. Here you don't need to do that. So if you go here, okay. So what I'm doing here is, I don't want to expose my credentials like username and password here. So there are two options. Databricks gives you something called secrets. You can create that object and then add your credentials to secrets, and then you can import that library and read those credentials here and pass um, secretly. Okay, Databricks secrets. But that API is not supported in the community edition. So for community edition, the workaround is you can set your variables as the environment variables. Okay. Uh, I have written another notebook called init. Okay. So in this notebook, I'm just setting the my credentials, the same, this code, this two lines I have written in that init, but I gave my actual username and password there. And when I run from this notebook, I can first call the other notebook to run from here. So I can say %run and give that notebook name. So it will first execute this notebook. Okay. So if I run this, it will automatically get the username and password, which I have set in this notebook. Okay. This I have shown you only as example. So you can move this to another notebook and put your actual username and password there. Okay. And then run that notebook from here. Just copy this cell, put it in that notebook with your correct proper username, password, and then run it from here. So once I run this, my username, password, which I have stored with Snowflake username, Snowflake password. Now here I can get, so I'm not executing this here because it's already executed from this notebook. This is for you as example. If I go here, I can get from os.getEnvironment this key. What is my username? Snowflake Snowflake password. So if I print, so it should get my username. So this is my username. This is what I used to log into Snowflake, right? So same username here. Password is also I have set. Now what I'm doing here to read a Snowflake table, basically spark.read format. Remember we used CSV, JSON, we used event hubs, we use all of that, right? Same thing, cloud files we used format. So same like format here, we use Snowflake. And then we have to give all these options to read. So what are the options? Host, I have shown you, right, in Snowflake, what is the host URL. So that same host you put here. User, I'm getting it from here, os.getEnvironment. That is DB username, DB password. I am passing those. Warehouse is compute underscore WH, right? So that's what, where is my, here. So compute underscore WH. This is my warehouse. Account admin is my role. Okay. Now, so compute underscore WH, username, password, host. I didn't give the role here. I think it's taking the default role that this user connects to. For every user, when he logs in, the username, password, he will have a default role. Okay. So that, and database, schema, table, right? So give all of this and that's run. That's it. Okay. But remember, you are using double processing here. One, from Databricks, you are using this cluster to run this notebook. When it connects to Snowflake, on the Snowflake, again, it's using this cluster to execute and give you the results from the database. Okay. So if you use Delta, it will be like same, this thing only that will be used, but it might have, here it might be using less power, there it might use more power if you use the data from Delta. It depends on how much cost and all of that. So that is it. Here we get the data. You can change, use this probably. We want to try this. So let's see if we can get this data. So I'm still using the same compute and everything, but I changed the table name, database schema table name. See, you get all the table here, and you also got this JSON format here as a string. Okay. So once you get this, again, from here, you can do your you can write this to your bronze table. Go back here, do your parsing on this, flatten or explode this JSON, write it to silver, put it in gold, all rest all is same. See, once you get your data frame, rest all is same in the database, same pattern, what you want to do. But this is all basic how you can connect and work. I think that is all. We heard a lot of stuff for you today. I leave at that for you to go back and work on these things. Okay. So account creation is simple. Snowflake, just go and see, 30 days trial, use standard. Okay. And this notebook I will publish, right? And then you can try it out. But within the Snowflake, go and play around with this. I don't know if this should be already there in the tutorial or online. You can check, or here also maybe you will get. I think if you explore somewhere, you will get all those tutorial. If you go to tutorials, you will get those. Yeah, just figure out. I think you should get from tutorials. There's nothing great in the SQL thing, but if you need, ping me. I can also copy this as in a notebook and then send it to you. You can just create new worksheet and copy and paste there. Okay. Any questions before we wrap up, guys? All good? You're liking what you're seeing?
Yes, Arun.
Yes, Arun.
Yeah, good from my side.
I didn't hear anything. There's some voice, some background noise.
I'm good. I'm good from my side, Harun.
I'm good, Arun.
Everything is good, Arun. Yeah.
Mhm.
I think it's coming from Nabi. Yeah, I heard you, Nabi. Thank you. You can go and mute. Anybody else? Any comments? Okay, Ramya, all good?
Yes, Arun. Yeah.
Okay, thank you. Thank you. Okay, Anirudh,
All good, Harun.
Anshu,
Yes, Arun. I'll
okay.
go through
Rahul,
plan and see.
Yes, Arun. Good from my side. Yeah, I was.
all right, guys, then take care. Have a good rest of the weekend. I'll publish the recording and the notebook by end of day today. And keep practicing the old ones, event hubs, Kafka, and then Snowflake. And how is your teaming up going on for the projects? I will ask Pawan to publish the assignment or the project. Basically using S3. These are all the components, right? We heard S3, event hubs, Kafka. Let's see how we can come up with the end-to-end project. Okay. But you still have to do the demos. Somebody on event hubs and some on Kafka. Then we will move forward. Okay. All right. Thank you so much.
Yeah.
Appreciate it.
Mhm.
Have a good day. Take care. Bye.
Have a good day.